Hello everyone, today I will present our data mining report, the report of bank marketing dataset analysis. Our team member is Xiqi, Eddie, and Meng Yao. Here's our outline of the project. First, we do the business understanding, and second, we do data understanding, and third, we do data preparation and modeling and evaluation, deployment, and references. First, in the business understanding part, the problem is that many banks are doing different kinds of marketing campaigns, so how to find a good method to help bank choose potential customers is a key question. In this report, we will discuss about two classification algorithms, association rules, and decision trees to help banks to make more reasonable data-driven decisions. The dataset we are using is Bank Marketing Dataset from UCI Machine Learning Library repository, which is related to a direct marketing campaign of a Portuguese banking organization. The bank made phone calls to give introduction to its products and try to convince people to subscribe a deposit. The dataset includes all the detailed information and whether the customer decides to subscribe the deposit or not. The goal is to predict if the customer will subscribe that deposit after the campaign. In the data understanding part, there are totally 11,163 records inside the dataset with 17 attributes. The attribute 1 to 16 are the independent variables. The attribute 17 are dependent variables. The first attribute is age. It's a numeric attribute, range from 18 to 95, with a mean of 41 to 23. Actually, that we can see most people are between the age from 30 to 40. The second attribute is job. It's a categorical attribute. It describes the type of job. So the category includes the management, blue collar, technician, administration, service, retired. The third attribute is marital. It's a categorical attribute. Includes divorced, married, and single. The fourth attribute is education. It describes the education level of the customer. It's also a categorical attribute. The fifth attribute is default. It's a categorical attribute describes if the customer already have credit in default or not. The category includes yes or no. The sixth attribute is balance. It's a numeric attribute in a range of minus 6,847 to 81,204 with a mean of 1,529. It describes the average yearly balance in euro. The seventh attribute is housing. It's a categorical attribute describes if the customer have a house or not. The eighth attribute is loan. It's a categorical attribute describes if the customer has a personal loan or not. The next attribute is contact. It describes the way to contact the customer. The 10th attribute is day. It's a categorical attribute describes the day of the week when the last time the customer get contacted. The 11th attribute is the month. Its categorical attribute describes the month of the year when the last time the customer was contacted. The 12th attribute is duration. It's a numeric attribute. Describes the duration of the call when the last time the customer get contacted. The 13th attribute is combine. It's a numeric attribute. Describes the number of contacts performed during the combine for a certain customer. The 14th attribute is p-day. It's a numeric attribute. Describes the number of the days that passed by after the client was last contacted from a previous campaign. The 15th attribute is previous. It's a numeric attribute. Describes the number of contacts performed before the campaign. And the 16th attribute is p-outcome. It's a categorical attribute. Describes the outcome of a previous marketing campaign. The 17th attribute is the target, which is deposit. It's a dependent variable, the only dependent variable in our dataset. It predicts whether the client will subscribe that deposit after the campaign. So in the data preparation part, we can see that the dataset is quite clean. There's no missing value found. the data set is clean and tidy, and so we just delete all the irrelevant attribute. Actually, we only delete the contact attribute, and we use the discretize filter to transfer the numeric attribute. The software we are using for that project is Weka. So in the modeling part, we do two classification algorithm. One is association rule algorithm, the other one is decision tree based on J48. For the first association rule algorithm, the threshold is the number is here. The number of rules is we generate 1,000 rules with a minimum support of 0.1, the minimum confidence of 0.9. So in the top 10 rules, auto confidence is 0.97 based on the 2 decimal. We find that actually the eighth root include all the first row to the 7 rows, and the confidence stay the same. So we can delete the first 7 rows if the customer doesn't have credit in default, and has which means the customer doesn't have credit in default and has loan of house, and the last time the customer was contacted was in May and not exist 85 days with the conversation less than 3,089 seconds, and the number of contact is less than 6, and the outcome of the previous marketing campaign is unknown. And in all this case, the combination all this case combined together, the customer leads to do not subscribe this deposit. The total of the rules we're finding is 251 based on our citing. There's is 251 based on our citing, and there's no rules find about deposit equal to yes, which means that the customer will subscribe a deposit, which means that all the rules contains deposit equal to yes has confidence under 90%. Actually, we have reset the minimum confidence to be 0.6, and the rules find was over 2,500. And we find that only a small amount of the rules contains deposit equal to yes. Most of the rules have the outcome that contains deposit equal to no. So the condition of dependent equal to yes has a large uncertainty compared to the condition of deposit equal to no. The second measure we are using is the decision tree method. We use the J48. So at first, we select the attribute by using information gain ranking filter. The first attribute to split is duration, which is the duration of the call when the last time the customer was contacted. This filter selects the attribute by considering the longest information gain. So here we can see that the first is duration, and when the information gain is 0.15, and the second is p outcome, the third is months, the fourth is p days. Actually, we rank all the attributes in our report. So after running the J48, we use F measure to evaluate the model and adjusted the parameters to get the highest F measure. The highest F measure we can get here is 0.834. And also, considering the size of the dataset, we adjust the size of the tree to make sure that it's not too large or too small. We set the reduced error pruning to false and the endpoint to true. So the size of the tree we get is 247, and the number of leaves we get here is 214. So we try to best to get our best F measure. So here the highest F measure we can get is 0.834. So here's a graph of the J48 model. So in the evaluation and deployment part, we can see that both of the two models above are not really perfect, and the dataset include the numeric attribute. So when we use these two models, we have to discretize this attribute, and this is not really good because it will lose some important information when we discretize the variable into an ordinary variable. But still that we can use these two models above to do the predictive analysis, since that For the first association rule model, it has a higher confidence around 0.97, and for the 7 decision tree model, it has a higher F measure around like 0.8. So actually, if you want to find a better way to do the data mining and find some data insight from this data set, we can say that you can use some other kinds of decision tree model and also try neural network or maybe k-means to get a better result, or see how we can improve the F measure. So we are open to any questions. If you want to have some discussion with us, just contact us. Thank you, everyone.